Hello everyone and welcome to the first episode of Coding with Cocktails. Tonight we're drinking an amaretto sour and we're making a multi-sig Ethereum contract. Let's get started. First thing we're going to do is we're going to set up our file. Let me start with a blank file. Let's delete this guy. So we're going to make a new file. We're in the Remix Ethereum editor. I'm going to call it multi-sig.sol. So we're going to tell the compiler which version we're using. So it's Pragma Solidity 0.4.21 is what we're going to use. We're going to make a contract called Multi-Sig. Let's do some comments saying what we want to do with this thing. I believe this is how you do a comment. So first thing we want to do is we want to create the multi-sig wallet with a group of signers. The signers can create proposals and sign proposals. The proposals have an amount, and it's basically a request to send money to somewhere. So a proposal has an amount, who has signed it, and where it's going. And then from there, we allow the multi-sig users to sign the proposal. So this is the plan. So we're going to create a multi-sig wallet where multiple users can autocomplete, create proposals to send Ether to an address, to send an amount of Ether. And then the other thing they can do is they can sign proposals and maybe reject proposals. Alright, so the first thing we need to do is we need to initialize the contract with the signers. Okay, so we need to initialize our contract with signers. The signers can submit proposals and they can sign proposals. To initialize, we're going to use a constructor. So we can pass in an array of addresses, and those will be the initial signers. 1 second. That's delicious. Alright, no visibility, so this needs to be public. And in here, we are going to say that we have something called signers. It's going to be a public, it's going to be an array of addresses, it's going to be public. Alright, so what we're going to do is we're going to set signers equal to the initial signers, and then from there we will also we'll make a map so that we can check really quickly if someone is able to sign. Mapping, so that'll be a mapping from address to Boolean, and we'll call this can sign. We can make this public too, I think. Alright, and then so basically what we're going to do is we're going to loop through the signers for uint I equals 0. So we're making an unsigned integer, starts at 0. It's going to go until the length of the array. This is pretty standard if you've done any JavaScript. It's very similar. So we're going to go the length of the array, and then we're going to add 1 to I. So in here, what we're trying to do is we are editing this mapping. This mapping is going to track which addresses are able to sign. So basically, when we're doing this so that very quickly, given an address, we can check to see if they're allowed, if they're an allowed signer. Okay, so we're gonna do can sign address. Address is gonna be signers. Actually, it should be init signers, even though they should be the same. Init signers I. We're gonna set that equal to true. Okay, and then so now what we have is we have the array of people who can sign, and we have a mapping so that we can quickly check to see if they are allowed to sign. So what we can do now is have a proposal. So first we need to define what a proposal is. So we're going to call it a proposal. Proposal. All right. This proposal has an address of who it's going to. It has an unsigned integer of the amount it's for. And then it has probably a mapping, so either a mapping or an array to track who all has signed it. We're gonna do an array. And the reason we're gonna do an array, you know what? Maybe we should do a mapping. Mapping. Yeah, we're gonna do a mapping. We're gonna have address to true to boolean. We're gonna have it called signed. Or yeah, that seems good. So basically, what's gonna happen is a proposal has where it's going, the amount it's for, and who has signed it so far. Okay. So next, what we need to do is we need to allow a signer to create a proposal. So we're going to have a submit proposal function. It's going to take in the amount, and then it's also going to take in the address that it's going to. And it's going to be public, and we probably should make it to where only a signer can call this, but we'll do that after. Let's see, so we're going to do, oh, we need an array of proposals. Proposal array public proposals. That seems good. Okay. All right. So now in here, what we will do is we will push proposals.push, and then in here we will push the proposal, and we will, let's give that a new line. We'll say, so it has 2, it's going to go to 2, and then the amount is going to be amount. That. Okay, so we've got some compiler errors here. Expected identifier, but got weird thing. It's probably because we should say that this is a function. Okay. So now that we have, are these indented? Okay, so this will, very simple, submits a proposal. Now we should make it locked down to where the person submitting it has to be a signer. So what we can do is we can make something called a modifier. A modifier is basically like a precondition for a solidity function. So it's basically a function that gets run before this function. So it will check to make sure that some condition is true before it's allowed to submit. So we're going to call this isSigner, and it's going to take in an address. We'll just call it user, and then we'll make sure that we will require that CanSign user equals true. Okay, and if that happens, then underscore. So underscore is basically like continue, run the rest of the code. So we're going to say that this is public, and then it has to be isSigner, and that's going to be the message sender. This probably is a little strange if you've never done Solidity before. So basically, you can put these conditions in to determine, to make this basically revert before any of this logic gets run. So it's going to run this first before it runs submit proposal. And if this condition fails, the entire transaction gets rejected. Okay, so I think we're at a pretty good point to test a very simple multi-sig contract so far. Basically, we've got the signers, we've got who can sign, and then we've got the ability to submit a proposal. So let's go ahead and test that out. So you can see I'm on the JavaScript VM. So this is like a local environment using all fake ether. So we are going to copy some addresses. These are my local VM accounts. I'm going to copy this address and say that it is one of the signers, and then I'm going to copy the second address and say that it is also one of the signers, and then I'm closing that array out. Let's make sure everyone can see what I'm doing here. So I've got this array. I've put the two addresses in here surrounded by quotes, separated by a comma. After that, I should be able to deploy. So I've deployed. So we can see this is the function that I have. It's public, so I can see it here in the UI. And then we can go ahead and check real quickly that one of the addresses can sign. This should come back true. And then if I type in like 0x0 and do can sign, this should be false, I believe. But it seems like it actually threw an error. Let's try pasting that and then changing this last letter to a D. False. Okay. So maybe I just need to do the full length full length of zeros. Yeah, that's probably the scenario. Proposals. We will see there should be no proposals. Nothing. Okay. Signers. You can get the first signer. This is the same as putting 0 in here. So this is the first signer, and then the second signer should be the second account that I'm on now. Okay. So all of that looks like it's working. Now we should do, so this is all measured in we, so let's do like some crazy big number. That's the amount that we want to propose to send, and then we want to send it to account 3. Now we don't have the functionality to actually finish the proposal yet, but we should see that it is created. It's just a test. Alright, so we're not allowed to send this. It got reverted, and that's probably because I'm on account 3. So that cost me some ether to try to do that, but it didn't work. So I have to switch back to either account 1 or account 2 to run this function. So let's try that again. Put some big number in here and then paste that account 3 address. So I'm on account 1 and I'm creating a proposal to send to account 3. Alright, so it should go through correctly this time. So if we go, we can see the Transaction cost 61,223 gas, and it was successful. These are the parameters. No events were logged. Okay, so that all looks good. That's about what I expected. So now let's go ahead and check and make sure it made it in there. So if we do 0 here for proposals, we can see that this is, let's check and make sure this is account 3. And the amount, that looks like the number that we put in there. Okay, so that looks like it's working. So this is sort of the flow that you would go to test in Remix. You write some code, compile it on this first tab, then you go to the Run tab. Make sure you're on the JavaScript VM unless you're trying to run this on testnet or using MetaMask or what have you. You make sure you have your correct contract selected here, and then you fill in your constructor arguments here. If they're addresses, make sure they're surrounded by quotes. And then you click this button. Now when you're doing it, it'll probably look more like this. But I have this Chrome plugin that makes my screen not have a lot of white on it. So I'm going to turn that back on because it hurts my eyes. Okay. So all of our code so far is working as far as I can tell. So I'm going to clear this and we're going to add some more features. So the other feature we need, so we've got done. We've got that done and we've got this done. Alright. So we need to be able to sign the proposals. Oh, and you know what? We need to be able to finalize or send the ether. Okay. Oh, and you know what? We also need to be able to receive ether. Just in general. So that one's pretty easy to do. To receive ether, your contract has to have a fallback function. So this is basically just a function that is empty like this. No name, no parameters, just an empty function. And then it is public and it's payable. So payable makes it to where a function can receive ether when you call it. And since this function doesn't have a name, this is considered like the receive function that all addresses have. It's slightly more expensive to send to a smart contract with an empty fallback function than it is to send to an account, which is unfortunate, but it is the case. I think it's just a few more gas, I believe. So this is done now. We can receive ether. That's all you got to do. All right. So the next thing we need to do is sign proposals. That's sort of a precondition to before we can finalize it. So let's go ahead and make a function called sign. It will take in the index of the proposal. Let's call it proposal index. Tricked me with that capital P, proposal index. Alright, so what we're going to do is we're going to get the proposal from that index and then we're going to sign it. So we need to do proposals, proposal index, and then from here we have a mapping called signed, so we can put the message sender in there. But we should also lock this down to where only signers can do it. So we're just going to copy our message.sender is signer. Okay, so is signer, you have to be a signer to call this function, otherwise it'll throw. If you are a signer, then you should be allowed to sign. So we will have .signed message.sender. Alright, so basically what we're doing is we are getting the message sender and we are making that the key in this mapping and we're going to set it to true. Okay, so that's pretty much it for signing a proposal. We should probably require that there is a proposal at that index. So we can make a modifier proposal exists, and it can take in an unsigned integer index, and then we can have it say require that index so the index needs to be greater than or equal to 0, and it also needs to be less than the length of proposals. Proposals.length. And then if it is, we're going to run the code. Okay, so that should stop us from signing or trying to sign a proposal that doesn't exist. So the order it's going to do that in, it's going to check and make sure you're a signer. If you are, then it will check and make sure that what you're signing is a valid index. And if it is, then it will run the sign function. Okay. Now the very last thing may be done. Let's put done question mark. We got to run the code again to make sure that that works. Let's go ahead and do that now, actually. So I feel like this is probably a good point to go ahead and compile. It's already compiled. We're going to redeploy this, so we're going to copy those addresses again. Got address 1. Okay, and then we can also test to make sure it can receive Ether. So that's address 1. This is address 2. We're going to close the array, click the deploy button. Now we have our contract deployed. Alright, let's go ahead and test the Ether receiving thing first. So from this last account we have, let's send it 5 Ether. And to do that, we're going to press this fallback button. So our balance went down by 5. The contract has received it. No errors occurred. So now if we logged out what the balance was or check the balance of this address, it would have 5 Ether. So that looks like it worked. So the other thing we can do is we can submit a proposal. Let's go ahead and copy this address. Let's pretend like we were trying to send this guy his Ether back. Can I copy this? It doesn't look like it. Okay. So I think it's 5 and then 18 zeros, but I could be wrong. 1, 2, 3, 4, 5, 6. Maybe that was 18. Who knows? I can't count. Okay, so we're going to submit a proposal. It won't let us do it. Let me copy this to verify. Okay, so we can't do that because we are not one of the 2 accounts that we started with. So we've already tested that. Let's try it now from account 1. Invalid address. I may have copied it wrong. Yep, it didn't do it. And then alright, submit proposal. I'm not sure how many zeros that was. Maybe too many, maybe not enough. Okay, so now let's see if I can sign this proposal. So let's check and make sure the proposal is there. Let's check index 0. So that's our proposal that we made. So to sign it, we can check our address, or we can just go ahead and try and sign it. Let's go ahead and try and sign proposal 0. We got pending, and it was successful. Okay, so we were able to sign it. Let's try and switch to an account that should not be able to sign it. So let's try and sign from this one. All right, it failed. So let's go ahead and switch back to proposal 2. Or not proposal 2, account 2, and sign it and make sure it works. Uh-oh, error. We're on one of the accounts, I believe. Something about our code may be wrong. So then we can try to do some debugging. So we actually are false for the signers. So let's see, 0 is CA something, and then, okay, 1, is there no other 2? There's no, okay, there's only one signer. So I did something wrong when setting the contract up. Proposals, let's go ahead and get proposal 0 again. Okay, so I think I created it with only one signer, but we're going to verify that. Let's try this again. We'll copy this address for sure, and then we will go to the next account, 147, copy that one, okay, let's make sure those signers are there. Okay, they're both there. We're gonna do a big number. We're going to make it to account 3 or account 5, whatever it is. Submit. Not going to work. We're in the wrong account. Alright, so now it should work from the correct account. Okay. So now from the correct account, let's sign it. And then switch to the other correct account and sign it. Alright, both of those worked. So now we need a function that can tell us if a proposal is finalized or if it is ready to send. Function is finalized or is sendable. And then that will be a index here, and it will be public, and it will, anybody can call this, I believe. It's okay to know if it's ready to go. So what we can do here is we can check the signers and make sure that all of them have signed it. So we can do another for loop. We can do starting with I at 0. So we're going to loop through all the signers, and then we're going to check the proposal and make sure that each signer has signed it. I less than signers dot length, and then I plus plus. Alright, so now we can check. So we can say bool all signed equals true. Okay, so we probably should start out at false. I don't know. We'll look at this in a second. So what we're going to do is we're going to go through the signers and we're going to check the proposal. Proposals at position index. Oh, this should also be a valid proposal. Proposal exists. And then proposal, that will be the index. Okay, so proposals dot signers signed. Okay, so this is that mapping on the proposal. I'm pointing at my screen as if you can see it. Signed, so we're checking this and making sure that each address from signers is in here as true. Proposals.signed, so we're going to say signers I. So this is going to be all signed equals all signed, and so we're going to AND it. So if one of these is false, then all signed will be false. and then we're going to return all signed. So what's it going to say? Okay, so we need to declare that this is going to return something. So the way you do that is up here, returns bool. So this is going to return a boolean. I think function state mutability can be restricted to view. Yeah, so we'll do public view. Let's go ahead and move these. To here. Move that one too. Just gonna have it to where the included keywords are at the end. Okay, so to find out if it's sendable, it needs to be a valid proposal. This is a public function. It's a view function, which means it doesn't alter state. It means it'll be a little bit cheaper to run. Okay, so from here we can check to see if a proposal has been signed by all signers. Now, if you wanted an M of N multi-sig contract, so a multi-sig where not everyone is required to sign, you would need to alter this function a little bit to count basically how many signers have signed, and then compare that to how many have signed it. Pretty simple. Okay, so the other function we're gonna have is to finalize it or to send it, basically. Close proposal, finalize proposal, finalize proposal. All right, so what this is gonna do is it's gonna take in an index, and then it will call, we'll make a modifier for if it can be sent. Modifier. I'm going to stick the convention of modifiers start with is, and function, this is can send, or hold on, it. Have all signed. All signers signed. Is finalized. Is fully signed. Is fully signed is what I want. Okay. So this will take in that index, and it will require that all signers have signed. Okay, so we're going to pass in index here. If that passes, then it will run our code. To finalize the proposal, it is going to require that it's fully signed, and also that, let's go ahead and say that you have to be a signer to do this. That way, no one else is basically triggering the send when you're not ready or whatever. Public. So there we go. What this is going to do is it is going to look at the proposal, see who it's to, and then send them the amount. We should also make sure that this contract has enough balance. So in here we can do require this. We have to do this as an address. So address this dot. I don't think I'm doing that right. I think it's actually address this dot balance greater than proposals index dot amount. Okay, so we're going to require that the balance is greater than the proposal amount. And then let's see here, is fully signed. We need to pass in the index here. And then what's it saying? Function state mutability can be restricted to view. All right, we're not finished yet. So if you can get past this require statement, that means you have enough ether. So then we can do proposals index dot to dot transfer, and then we can transfer them the proposal amount. Okay. Let's go ahead and put bool finalized. So we're going to start finalized out at false. Finalized false. This is going to let us know that we've already finalized one. It's already been sent. We don't need to send it again. We should make a new proposal. So for that, we should also require that the proposals not already finalized. And then after that, we'll set it to finalized. Index dot finalized equals true, and we'll do that before we send it so we don't get any weird re-entry problems there. Okay. So we've set it to finalize, we transfer the amount. Let's go ahead and get a balance thing to, let's go ahead and say function balance, takes no arguments, it's public, and we'll just return address this dot balance public view different number. Oh yeah, we need to do returns uint returns. Okay. Let's go ahead and test this stuff again. So now we've added, we know that this works. We've added finalization, and then this should be able to send ether now. So I think we have a full set of features to actually test a full run through of this. Let's go ahead and copy the address for account 2. So copy that, and then let's go ahead and copy the address for account 1. Paste that. Go ahead and deploy it. Okay, so we've deployed our contract. Here it is. We can see what the balance is. The balance is 0. We will switch to a different account. We'll pay this guy, give him 10 ether, big baller. Send it to him, check the balance. All right, cool. Switch back to the first account and create a proposal. This proposal is going to submit proposal. We're going to send this full amount, and we're going to suggest that we send it to account 1. This guy thinks the money should go directly to him. Okay, so we're going to submit the proposal. It's been submitted. We can check and make sure it's existing. Here we can see it. Finalized false amount like that. Okay. And then here we can check to see that all signers have signed. Should be false. Okay. And then we can sign proposal 0 as account 1. And then we can switch to account 2 and sign proposal 0. Alright, and then when we run all signers signed, it should say true. Alright, it says true. Our balance is still this big number. So it's been fully signed by each account. Now let's test out the finalization. So we're still on an account that can sign. Let's go ahead and try this from someone else. Finalize proposal should fail. Okay, it failed. You can see that here. So let's switch back to an account that can finalize a proposal. Finalize. So this account balance should have gone up, but it didn't. Something failed. Revert. The transaction has been reverted to the initial state. The constructor should be payable if you send value. No, we weren't trying to send value. We were trying to transfer this ether, man. What's going on? Oh, don't do that. Okay. Let's take a drink and think about this for a second. Oh, my amaretto sour is watered down. So we have proposals, index 2, and then transfer. So maybe let's check out this. Let's check out the logs here. Let's check the balance. Let's see if it sent anything. Okay, so the balance is still real big. The transaction has been reverted to the initial state. Let's see if the proposal is finalized. So it's not finalized, so that means it is failing. Ah! Ha ha ha, I see what it is. So this line here says the balance is greater than the amount, but it should be greater than or equal to. Programming gets you places. Alright, so to fix this, our contract has a bug. Isn't that so cool? So we're gonna send like a tiny amount. We're just gonna do 100 GWay. We're gonna hit the fallback function, and now the magic happens. We're gonna finalize it. All signers have signed. This is still true. But when we go to finalize now, it should work because our balance is greater than the amount. Did it work? And the crowd goes wild. You have 110 ether. That's awesome. Okay, so that was that bug. It's pretty tricky. So the way I figured that out was, since finalized didn't get set to true, that means it failed somewhere in here. I knew that it didn't fail here, so it either had to happen here or in one of these things. I knew fully signed is true. I knew is signer is true, so it has to be this line. This is the only possibility. Okay, so we've got a somewhat functional multi-sig contract now. Comes out to 84 lines. We can do M of n, and then I think that we'll be done. Okay, so we will require, so what this means is, say you have a multi-sig contract with 10 signers, but you only require that 3 of them agree that a proposal should be sent. So what you would do is check to make sure, for fully signed, you return true when the amount of people signed is greater than or equal to M or 3. So we're going to make a uint signers required. Signers required. Okay, so what we will do is, if you don't give M, signers required will be all of them. Okay, so if you don't give an M, it defaults to everybody has a sign. Otherwise, we're going to do if-else statements. Okay, signers required equals M. Okay, so then in our all signers signed function, we need to change this to say proposal signer requirements met. How about that? Signer requirements met. Okay, so this is gonna require that signer requirements met is true. Okay, and then we're gonna change the logic to say uint signed count. We're gonna start out at 0. And then we will add 1 to signed count if this statement is true. So if proposals, so if this person signed it, if this address signed, for each signer, if the signer has signed, increment the signed count. Signed count plus plus. Return signed count greater than or equal to sign, what is it? What do we call it? Signers required? Signers required. Okay. So we just changed this logic. Instead of doing a Boolean expression, making sure that every signer has signed, now it checks, it has a counter, and it counts how many people have signed it. And then if enough people have signed it, if you're greater than or equal to the signers required, then we will return true. Otherwise, we'll return false. So that little change should make it to where we have an M of N contract. Let's go ahead and test that out. So we're going to copy this address into here, and then we'll do address 2 here. Alright, and then so that's argument 1 of the constructor. Now we need to do M. So we're going to say that 1 signer is required instead of 2. Let's deploy this bad boy. Alright, so we're going to go to this other account. We're going to send some ether. We're going to send 50 ether. We're gonna hit the fallback here to send it. So our balance is reduced. We're gonna go to this guy, and we're gonna copy his address. And then first, let's check the balance. Yep, our ether's there. Okay. So we're gonna submit this proposal. We'll go ahead and paste that in there. This is that guy's address. We're gonna copy this, and we will paste it here before their address. So we're creating a proposal for all of that ether that was received to go to this signer. Is basically sending all of the balance to himself. Or is it? Let's see. Finalized false. Let's check. If this works, we should be able to sign it, and then it should say, first let's check and make sure that the signer requirements met is false. So it is false. Now let's sign it, and then check them again, and it's true, so that means that we can finalize this now. So we can get this ether out. We're going to finalize the proposal. Check mark here. And yep, it worked. So account 1 now has 149 ether. So that's how you implement an M of N multi-sig contract in Solidity. Hope you guys enjoyed. This is a preliminary step for me making my Solidity contract developer course, which should be up on Udemy at some point this year. Until next time, cheers. I got an ice cube.